Episode 2: Observation and Deduction in Forensic Science. When people think about forensic science, they often picture dramatic DNA matches, fingerprint scans, or even advanced laboratory machines. While those tools are incredibly important, every investigation actually begins much earlier, with observation and deduction. Before any evidence is tested, forensic investigators must carefully observe the crime scene and think critically about what the evidence might mean. Observation and deduction guides every decision that follows, from which evidence is collected to which tests are performed. In this episode, I'll explain what scientific observation really looks like in forensic science, and how deduction helps investigators reconstruct evidence, why document is essential, and why avoiding bias protects the integrity of an investigation. Scientific observation. Observation in forensics is very different from everyday observation. In daily life, people often jump to conclusions without realizing it. In forensic investigations, doing that can lead to some serious errors and even wrongful convictions, which is not good. Scientific observation is intentional, systematic, and objective. Investigators are trained carefully to record what they see without adding opinions or assumptions. Their role is not to solve the crime immediately, but to gather accurate information for later on the road. For example, stating there's a red stain on the floor near the doorway is an observation. Saying that the stain is blood from a violent struggle is an interpretation. Forensic science must clearly separate what they observe from what they think happened. Observation also includes noticing details such as position of furniture, signs of forced entry, lighting conditions, weather, odor, and whether objects appear disturbed or missing. Even small details like whether a window is open or closed can be significant. These observations form the foundation of the investigation. If an early observation is inaccurate or incomplete, every conclusion that follows may be flawed. Deduction. Once an observation are recorded, investigators use deduction. Deduction is the process of drawing logical conclusions based on evidence and the established scientific principles. Bloodstain pattern analysis is one of the clearest examples of deduction in forensic science. Investigators examine the size, shape, and distribution of blood stains to determine how an injury occurred. Round stains often indicate passive bleeding, while elongated stains suggest movement. Cast-off patterns may indicate repetitive blows with a weapon. Another example is footwear impression analysis. The depth and direction of the footprint can help investigators deduce whether someone was running, walking, or carrying weight. Trend patterns may link a shoe to a suspect. Glass analysis also relies on deduction. The shape and the direction of the glass fracture can indicate whether a window was broken from the outside or the inside. It is important to understand that deduction must always be supported by physical evidence. Investigators do not guess. They reason logically based on observable facts. Documentation. Because human memory can fade or even become distorted at times, documentation is one of the most critical responsibilities in forensic science. Investigators document everything using detailed notes, photographs, videos, and sketches. Crime scene includes time, condition, observation, and actions taken. Photographs capture this scene exactly as it appeared before evidence was disturbed. Sketches provide measurements and spatial relationships that photograph alone cannot always show. Document ensures transparency. It also allows other investigators, forensic analysis attorneys, and jurors to review evidence objectively. If something is not documented, it may not be reliable in court. Bias and objectivity. One of the greatest threats to forensic science accuracy is bias. Bias occurs when investigators allow personal beliefs, expectations, or outside pressure to influence how they interpret evidence. For example, if an investigator focuses too early on one single subject, they may unintentionally ignore evidence that contradicts their theory. This is known as confirmation bias. It happens a lot, and that's what leads to wrongful convictions. To prevent bias, forensic scientists rely on standardized procedures, peer review, and evidence-based conclusion. Observation comes first, and deduction may always be supported by a fact, not opinions. real-world significance. Many wrongful convictions have been linked to poor observation, weak deductions, or investigator bias. Modern forensic science emphasizes training and accountability to prevent these errors and protect justice system. Observation and deduction are the founding for forensic science. When used correctly, they allow investigators to reconstruct crimes accurately, fairly, scientifically. Without them, one of the most advanced forensic technologies would be meaningless. Every detail at a crime scene tells a part of a story. The position of an object, the pattern stains, or the condition of the room may seem small on its own, but when observed carefully and analyzed thoroughly, those details can help reconstruct exactly what happened. This allows forensic scientists to move beyond speculation towards scientific truth. Equally important is the role of documentation objectivity. By recording observations carefully and avoiding bias, forensic investigators ensure that their conclusions are based on evidence rather than assumption. This protects not only the integrity of the investigation, but also the right of everyone involved. History has shown that mistakes in observation and bias deductions can lead to wrongful conviction. Because of this, modern forensic science places strong emphasis on training. In the end, forensic sciences is about uncovering the truth. Through careful observation, logical deduction, and unbiased reasoning, investigators can reconstruct evidence accurately and ensure that justice is based on facts, not guesses. These skills remind us that sometimes the most powerful tools in forensic science are not machines, but the trained eyes and minds of the investigators themselves.